All right, in this lecture, we're going to look at how to actually manage the device state. So you have your IoT devices connected to the AWS IoT services, and then how are you going to actually manage the state? Basically, how do you control your devices and then synchronize the state to whatever the client is. The client could it be the web or a mobile app or some other services that are interested in the state of your device. So we're going to actually take a look at how to do that. We have learned an approach before to use server-side events, and we push the status from the devices back to the UI on the web. That's one way to do it. That's basically based on the HTTP protocol. Now, we also going to this time through this AWS IoT, and let's take a look at alternative way of doing it. Basically, the UI will not be talking directly with your backend device. And because now we're going to use a different protocol, the MQTT. Basically, your devices will communicate with the MQTT broker, as well as your clients. They communicate with the broker, and then, of course, for security reasons, they all need to authenticate. And so, in the last lecture, we looked at how to actually authenticate your device with AWS IoT, and that's basically based on the certificate. So if you still recall, that's using the client certificate cryptography, and so that is how that is done on the side of the Pi. For instance, we're running a Python program on the Pi. Now let's take a look at a little bit more complete example. We want to have the Raspberry Pi be extended with our classical example of LED, which is going to control a single LED. And we want to synchronize the state between the UI and the LED. So the LED portion, so let me kind of show you the idea, let me kind of explain. I'll explain this program here. So I want to really, first of all, you need to understand the thought process. So let's say right now, so for the sake of time, and I'm going to show you the Pi, and you already know about this, so there's nothing really special about this LED. So get your LED installed on the breadboard, and the idea is we're going to run a program on the Pi, and this program will basically communicate with the MQTT broker, and it will always try to synchronize the state of the LED is on or off based on the messages that are sent to the broker. So essentially, the communication between the client is going to issue a command in the form of MQTT messages. And those messages are delivered, published to MQTT broker. And this program that we run on the Pi is going to subscribe to the broker, listen for those messages. Essentially, those messages will be controlling the LED on or off, okay? So it is a little bit different. In the case of REST API, we have the client, the UI, directly control by issuing a HTTP call, and that will change the state directly because we have a Flask server, we have an HTTP server running that will take that request directly. So the UI communicates with the backend server, with the Pi directly. That's how it was done before. Now, they don't communicate directly at all. They both talk to the broker. The broker is the middleman. So that's a different concept. This process of communication is asynchronous compared to the HTTP call, which is synchronous. You give a command, you send a request, and then you wait for response. And here, there's a middleman that breaks that direct synchronous communication link, makes this whole process asynchronous. So it's a little bit different style. Let's take a look at the, let's actually, let me open up actually, let me move this to a different tab. Just kind of want to focus. Hold on. All right. Let me combine this. Okay. So these are the two things actually we want to take a look at. So I'm going to close this for now. So over here. Actually, let's take a look at the documentation. Device shadow. It becomes a little bit more clear because the documentation is fairly good. So in the previous lecture, I've shown you how to actually publish a message, how to subscribe, also a message from the broker. The broker is just MQTT broker, and there's nothing special about this one. This is hosted by Amazon, and it's got more security protocol around, and so we have to, we can't bypass the security. We have to kind of follow that. That's typical when you run your application. Now, every MTTP broker will have reserved topics. So in this case, for example, the reserved topics starts with a $AWS. So follows a particular topic naming convention. Suppose your thing name is the name of your thing. It's called a thing name. And then this topic here, that is basically the so-called classic shadow, because the AWS supports multiple shadows that are named. In our case, we're going to just use this unnamed shadow, which is also the classic shadow. And this is the path. This is basically the topic. And the topic, if you really kind of compare this with HTTP or REST API call, it's like the path of this URL. But this is different here. We're talking about a topic. Now, the way for okay, so when you bring up your program on the Pi, let's say, now first I want to know, so the Pi needs to know the state. It wants to know the state of the current. Now, so I don't know if I explained what is a shadow. A shadow is just it's a JSON document. Okay, to put it a very simple way, it's a JSON document that's stored in a database somewhere handled by AWS, and then it provides a service around that document that allows you to retrieve the document through both REST API and MQTT protocol. So this document represents the state of the device. For example, if the LED is on or off, or If you have a colored LED, is it a blue, green, or yellow right now? Or if, let's say, you have a temperature sensor and then you publish the temperature reading periodically, so that will also be your state. So there's, many different things you can do. So the idea here is the shadow represents the status or the state of your device. You have many sensors or actuators or whatever is going on with your device, then you can represent that in a JSON document, okay? So that is the shadow. Now, how do you retrieve the current state? The way to retrieve the current state is by publishing an empty message to this /get. So remember, this naming /thing name /shadow, that's the topic prefix. And then you add that prefix to /get, so this whole string that becomes the topic. So you would publish an empty message to this topic. So let's say from your Pi, the Python program running on your Pi, you want to retrieve the state, so that when you bring up this program, you need to want to synchronize the state of your device with the shadow. So what you do is you publish an empty message to this particular topic, okay? You publish to the particular topic. Now, remember with MQTT, you don't just get a response back. It's not an HTTP call. So you can publish, you can also subscribe. Those are only the two things you can do. So when you do subscribe, and then you can listen to the responses. So let's say you publish this get message. You publish a message, basically empty, to the /get topic. Your intention is trying to get the current state of the shadow, right? And let's say that computation takes, let's say, a month to complete. That is totally fine. So after a month, whatever is computing that request, okay, so let's say you have another service that can listen to this topic. So you send this /get, right? So that request sent to the that message into the MQTT, you have a service that's going to listen on this /get. So then they're going to process, and it takes 1 month to compute. That's fine. I'm kind of trying to give you an idea of this whole asynchronous nature. And then once it finishes, what that service is going to do is it will publish a message to MQTT to a different topic that says /get/accepted. And then that basically, that service finishes its computation and now got the whole state document, and it publishes that to that topic. And then your program that issued the initial /get message, you're trying to get the state of the shadow, right? So after you've been waiting, you waited a month. Now, since you subscribe to this topic, /get/accepted. Now, since the other service finished computation, they send a message to MQTT broker, and you're listening on that. Now you get that message, which is the response of your GET request. So that's how this request works with HTTP call on REST API. You call and you have to keep waiting. So you have a connection open, you wait for the response. Here, you actually do not wait. Basically it's a whole asynchronous nature. So that's kind of the advantage of MQTT. Okay, so I hope now you understand how this communication works. You send the request, or you want to get a response. It's all through either publish or subscribe. That's really the only two actions you can take with MQTT, basically. Well, there are other things, but these are the primary actions you can take. Like connect is an action, disconnect. So that's not count for those, but typically you do publish, you do subscribe. And then once you subscribe, you're passing a function callback. And so when that message comes, and the callback will be called to process the message. So that's really the idea here. Okay. Now, let's say we want to control from the UI. That means we want to turn this on and off. So we're going to use JavaScript, HTML again. It will be similar to what you saw before with the example of the week before. So you've seen that UI that we worked on. So it will be a very simple example here. We're going to only have a single component that represents the LED status. So on the UI, we want to click on a button to turn the LED on and off. So the UI will need to also communicate with the MQTT broker and then be able to update that status. So the way to do that is by sending the status, the state document, basically the change you want to make to that /update topic. And then your Pi, the program running on the Pi, that will listen on /update/accepted to process the response. So essentially, the UI sends an update with the information, what kind of status it needs to update to, and then on the Pi side, you listen on this /update. Well, actually, we're not necessarily interested in /update/accepted, because if the LED is on now on the, on the client side, and say, oh, I want to continue, I want to update this to on, so there's no change. And then we're not interested in no change update. We're only interested in some changes. So we're going to actually listen on this /update/delta on this particular topic. So this basically says if something actually changes. So that's what we're interested in. So then we're going to listen on this /delta instead. So then the callback on the Pi side is going to then turn the LED on or off. So that's the idea. I want to explain this first before getting to the program so that you don't get lost. Now let's take a look at the program. First things we want to do is, okay, so on the Pi side, now keep in mind though, this Pi program is no longer a service in the sense of providing an API. It's not an API service anymore. Not in the traditional sense, but this is a program that will keep running as a service in the sense that it runs on the operating system like a Linux service all the time, because it needs to process the message and synchronizing the state of the LED. So since we need to communicate with MQTT, we look at the example before, but to really use this in a program, well, that was not very suitable. So you want to encapsulate that functionality of MQTT connection, or subscribing or publishing into a class, and that usually is a good idea. So we're doing object-oriented programming here. So we designed a class here called AWS IoT client. And well, in the constructor here, we're going to actually take a couple of parameters. So you can pass in the broker port, the broker host, and then the certificates, or a bunch of them, the private key and the root CA. And also in this, we may take an optional on connect. If there's something that you want to do in the on connect, then that can be done here. Well, typically the on connect is not that interesting. So by default, it's going to be none. So there's nothing that needs to be provided. And so in the constructor, we're going to make using the pothole library to make a client object, and we're going to initialize TLS. So this is the same as before. So now we just kind of generalize that program and turn that into a class. So we can reuse the code, and it's more clear this way. So if the onConnect callback is provided, and then we're going to remember that. And then this will be set on to the internal client. And then we're going to actually make the connection, and then we'll do the loop start. The loop start basically will start a background thread that will do the processing of the messages. So, and then the primary methods we need to provide is publish. So we want to publish a message to a particular topic. So first we need to turn the message into a string with a JSON library, the JSON module, and then we do the client.publish on that topic and a message. And so this is the same as before. As you see, we turn this into a method here of the class. And then the subscribe. So this is the other primary action is subscribe. And here we're going to actually take a list of topics that you may want to subscribe to multiple topics. As I just explained, we're interested in the get accepted. We're also interested in the update delta, right? So there's multiple topics we want to listen to. And then we're going to provide a message callback. And so over here, in fact, because we're doing, encapsulating this whole MQTT functionality, this message callback, we try to make that callback a little bit more user-friendly. The callback will not need to be concerned with MQTT itself. So here's an example. The callback is going to actually take parameters of this AWS IoT client, and then the user data, which is kind of any kind of an arbitrary data that you may be passed along, but this is normally not used. There may be usage, but in our particular case, we're not going to use it. And then we're interested in the message, which already turned into a basically a object in Python, typically a dictionary. And then the topic is also presented. So this is a more user-friendly. So on the user side that want to use this class, they don't need to deal with any of the MQTT stuff. The whole MQTT has been encapsulated. Okay. But then our internal client, that's the pothole MQTT client, needs to actually take an onMessage property that will need to be. So what we do here is that is still gonna. So here we're using a lambda here. That's using this parameters that I've shown in the example before. So we do this a little transformation here. So instead, we're gonna call the on-call callback, on-message callback with the self, which is the object for this AWS IoT client. And then also we're gonna turn the response of the message. Actually, we're gonna turn that string from the payload field back into a object, basically a dictionary most of the time. So make that a little easy to use. This is a little conversion here. And then the other thing is want to subscribe, and then want to actually add the subscribe action inside the onConnect. So the regional onConnect may be provided in the constructor. So that's optional. If it is provided, we're going to actually call that. We'll actually make a new function here that will call the original onConnect, but then also on top of that, we're going to actually subscribe to the topics. And so here, there's the list comprehension here to turn each topic into a tuple of topic with the quality of service. So here, I'm going to just use 0. The lowest level quality of service. And then we're going to assign this new onConnect function into this internal client. So that's really the main thing, and then there's some test code that actually verifies that class is working. So this is still very much the same as the before that I've shown you, except here we'll turn this into a decent class that can be reused. So now with that little module here, so now we're going to do is, so here, so we're going to actually import that module, import this class from the module AWS IoT client. Now remember, if you want to turn a Python program into a module, the name has to be basically underscore. You cannot use dashes. That's the naming constraint. So here we're going to actually make an object of LED. This is the same, GPIO0 library, and this you already very familiar with the pin number here. So I'm using 18. You can use whatever you need. So we have some constants here. So when you are running, in your case, this you can keep the same. This is the same. Will continue from the last lecture into. The broker host, yours will be different. Obviously, this is all random string here that's generated for your account. So you modify that appropriately, and so you can obviously put this into a .env file as well. But so here, for simplicity, we're not doing that. So you can just modify the program for your local testing. Now, let's take a look at the main function here. So first, we'll create a client object using this class that we just made. So we're passing the broker host. We're going to use port 443, and we're going to pass in this couple of certificate files. Okay. So here we're still using the pure path, just so that you don't get into trouble when you run this program from different directory. That's going to always work. Okay. So there's a lot of enhancement here, just kind of avoid the whole path issues. And what we need to do here is we subscribe to some channels that will want to listen for messages. So the get accepted, update delta, as I explained before, and then this is the shadow topic prefix. Shadow topic prefix, as I just shown you in that document, this is the one. Okay, it's the same as what's documented on the AWS website right here. Okay. This is the about the device shadow and MQTT topics. So this is what we're using here. Okay. All right. So we subscribe to this too. And there's more, obviously there are more topics that you could subscribe to that if you're interested in handling them. So here, for simplicity's sake, we're gonna just listen to these two topics. And then this is the message handler, the callback. And I'll show you the callback in a second. So here, I'm gonna actually do a little pause here, sleep for a second. I just make sure the connection is made before we actually publish a message. And see why we'll publish a message here. So this is what we're doing here is basically we want to get the current state of the shadow so that we can synchronize that state with the LED status. So essentially what it means is as long as your client could be controlling your LED on or off, but then let's say your Pi has been disconnected, power outage or Wi-Fi got broken. It doesn't matter. So the client, let's say, turn that on, but the backend has been disconnected, it really cannot do anything. So what that will do is, as soon as that Pi gets reconnected again, and then it will basically, now gonna fetch. We're gonna actually publish message, empty message to that /get. We'll wanna get the current state of the shadow. Okay, so that's where basically we issue this get command here, and then we're gonna handle that response on this topic with this message function here. And so when we get a response, then we're gonna read what is the current status of the LED supposed to be based on the shadow, right? So if it's supposed to be on, then we're gonna turn the LED on. So you see how that works? The shadow becomes a way to handle even your backend, device is unreliable, the network may be disconnected. When it comes back online again, that state will be synchronized with the device. Okay, so it's pretty neat. So let's take a look at how we actually handle. So the get accepted, that's the response from the device shadow service that will give you the response about the current state. So we're going to get that message here. If the topic ends with this, so we have to now examine what kind of topic, because this is handling multiple topics here, right? So if the topic ends with /get/accepted, and then we're going to examine the LED on property. The LED on property, by the way, is a custom property that you just make up. You can have many sensors, many things that you're trying to monitor or represent in that shadow, and you make up those properties. So how does that document look like? So if you actually take a look at this, and let's take a look at the response state documents. So the JSON looks like this. The response in the get accepted, it'll have a state and desired. Now, what does desired mean? Desired means is this is the state of the device that's supposed to be, even if your current device is not in that state. So this is what desired means. The desired, so is that's the state that the device needs to synchronize to. And then as you see, then you have attribute 1, attribute 2, whatever. So let's say we're gonna have a LED on attribute. Then you wonder, okay, where is this document created? This will be created from the UI. Okay, the UI does the control, it'll turn this on or off. So it will actually generate that initial document, which will put in the LED on property in that document. So we're going to basically get this state desired LED on. So we're basically navigating that whole nested dictionary. If the LED on is true, we'll turn on the LED with LED.on. So this you're familiar already, right? So if otherwise, we're gonna turn that off. Okay. And it may not do anything. If your LED when you start up and is off, and now the desired state needs to be off, and this is basically no op. Okay. Now, the other message that we're handling is the update. So as we control from the UI to change the LED status, and that's going to actually send a message over to the broker, and then we want to listen to when there's a change from the UI. Let's say it used to be off and now is on, or used to be on, now is off, and then we want to make a change. So in that case, we're going to turn this on if the LED on in that state document is on. So this is this document specification is all basically described right here. So if in the case of an updates delta, and then you can look at that delta response, which is basically state and attribute, right? Okay, so that's the update. So this is basically the backend program. Okay, fairly straightforward. It's a little more clean now since we turned the MQTT function into a class. Okay, let's take a look at the front end. So let me actually open this up in the browser first. So as you see now, this is very similar to before. In fact, I just use the same kind of a code just to show this UI-based control. All right. So before I start running this thing, now while the UI is running, the backend does not need to run, by the way. As you remember, this is going to communicate with the broker and then change the shadow state. So that's really what this is about. And then when the backend comes online, it will synchronize with it. Okay. So where do you find that document? So the document you can find under this, let me go to this initial page here. So you go to this AWS IoT, you can search IoT right here. This is how you can open. So IoT core, okay, that's the service. And then you go under this manage things. And then this is the thing too. And then click on shadows right here. Now I have something here because I ran the program before. So let me actually delete this first. And back to shadow list, you can actually click on this 3 dots and remove shadow. Okay, so we'll start from the beginning. Now, if you don't have any shadow to start, and then if you refresh, your first time you load it, it's trying to retrieve, because we also want to synchronize this button here, the status, the switch to be the whatever the state of the shadow is. So you see, we also want to synchronize our UI. This is a representation of the LED status. So of course, it wants to load up that shadow. Now we don't really have a shadow, nothing is there yet, right? So that's why you see a failed call. It gives you a 404 response, and this is the message that's printed out from the program, and the UI program actually knows, okay, it cannot make a call, there's no shadow. Okay, so it prints out no shadow. This is normal. This is the very first time. So because we actually don't have any shadow in here for this thing, right? So you have to refresh again. And as you see, we'll confirm there's no shadow here. So what we do is, now let's say I want to turn on the LED. And by the way, if your backend program is running now, you run this AWS IoT LED. If you run this, right, and I right now have this running, by the way. So if you don't run, that's fine. That's going to actually update the shadows document either way, whether you have the backend running or not. It does not matter. So if your backend is also running, you'll see the LED turn on right now. Okay. So I'm not going to show you in the camera for LED because that's already very familiar to you. So you will complete that part by yourself. And this will turn on the LED. So the light is on. And then because you turn this on, I'll show you the code in a bit. So this actually will this will create the shadow document, basically. So we're gonna refresh this page again. And then click on shadows. Now you see there's a classic shadow, basically means this is the shadow without a name. And then you can have many other named shadows if you want. But here, this is what we're using. So click on this classic shadow, and then you'll be able to see the shadow document. So the shadow document, you see the shadow state. It has a desired field and a reported field. Reported means that's the state reported by the device. Desired means that from our UI, we try to control the device. We're turning this device LED on. That's what we do. That's called desired. And these two may or may not match all the time. Let's say while you turn the desired to be on, your backend has been disconnected and it used to be off. And then this would remain off because that has not been updated. Okay. So actually, let me show you one more thing. Maybe you did not pay a whole lot of attention here when I was explaining this on the message handling in the back end on the Pi. So one thing to note is, so when the front end update the LED to a different state, that's why we listen to the delta. If it used to be off, now it's on, or so now I want to handle that, right? So we turn the LED on and off, but once that is done, though, there's one more thing we need to do is to update the shadow, right? The shadow actually needs to be updated with the current state. So the update status, that is basically we're updating this reported field. This is coming from the device. So now we're telling you the device is on or off. So this is what this report is about. And desired is what's going to be used on the UI. We're going to say, I want to control this to be on or off. That's the desired state. The backend needs to be in. So once the backend is actually turned on, it will report to say, now it's done, okay? All right. There's actually a metadata that I'm gonna just ignore this part. It's not that interesting, and so this doesn't serve our purpose here. So focus on this part. That's the shadow state. Okay. So if we turn this on, the LED goes on. Turn this off, LED turns off. Actually, there's some. You see, there's some debug statement that's printed out. Okay. So how is this done? Let me show you some JavaScript code. This JavaScript is not really the focus here, but again, the real world application, I want to show you something more realistic. So we're using some JavaScript here, all right? Also keep in mind, if you write a JavaScript, you can actually deploy your JavaScript application you can actually build that as a mobile application. So there's libraries that you can use or tools you can use to wrap your JavaScript application as an iOS app or Android app, okay? Again, mobile app is not our focus here, so just let you know that's a possibility. So let's take a look at our index.html. This is the entry point for the JavaScript app. It's HTML app. Now here, everything is very much similar to before. As now you have seen, okay, we have some HTML structure here. Essentially, there's a div of app, and then here we have a title, and then we have the LED component. All right, and the LED component is in a separate JavaScript file. So as usual, as before, and in fact, this is very similar to this the ARM control, right? The ARM switch, if you recall the ARM switch. So essentially, this is a switch. We'll switch this on and off. And so I'm not going into too much detail. It's very much mirrored to the ARM switch thing. So here I want to show you so when this component is rendered, well, the initial thing we're going to do is when that is mounted, the component is mounted, we're going to check status. And then this check status is a method here. And then what we're doing is this AWS client is a constant, is an object that's passed on to this component from the index.html from the parent. And we're going to call this fetch method. And we're passing this shadow URI, which is also passed into here as a constant. And I'll show you right here. So right here, we make an object of this AWS client by using this little module, AWS for fetch. And then this allows us to actually authenticate with AWS because now this is one way to authenticate is to use a access key. So I'll show you how to create this access key in a second. So we have this AWS client, and I also want to pass the shadow URI to the component, the LED component as well. So this is shadow URI. So we have the IoT endpoint. This is the same as the MQTT broker. This is the same endpoint. So except here, we're going to use HTTP call. Now, the reason I use HTTP here is because it's simpler to handle. It's a little more complicated to set up to run this in a browser if we use the MQTT protocol. It's not impossible, it's just a little more complicated. So I want to show you a simple scenarios. We're using actually HTTP call here. So the shadow device shadow service supports a REST API. So that's what I want to show you here is a REST API. It's right here, device shadow REST API. And then this is the API we're going to actually use. You know, specifically, we want to be able to get the thing shadow or update the thing shadow. These are the two APIs we're going to use. So essentially a get call and a post call. This just like a REST API. Yeah, so we'll pass this on, and there's really nothing here. This is a very straightforward. And then so over here, so this is what we're doing here. We're using the AWS client, which will do the authentication with the AWS, and needs some kind of a signature passed on to the HTTP call with some cryptography to prove that you are who say you are, and it's an authentication method. So this is what this library allows us to do. This library, AWS for fetch, handles the AWS request signing. So we'll do the fetch, and then we're going to handle the response. If the response is okay, we're going to turn that into a JSON object. If it's not found, the 404 is not found. Not found scenario is the very initial case. Remember that when we printed out in the console, no shadow. This is where it's handled. So if there is a shadow document, and then we're gonna, now we're gonna read that data, which is gonna follow that state reported LED on. So want to get the value, the reported value, want to synchronize that to the front end, to the UI. So then we change that LED on attribute to be matching whatever is reported. So that's determining whether this switch is on or off, all right? And then if I turn this on here, that means I'm changing that status. So we're actually making a post HTTP call to the shadow device service or device shadow service. And here, this is the document we post to it. Is that state desired LED, this value is true or false, all right? This is when we click on this, on or off, and it will invoke this method here to publish this document to the, this is basically the API here we're calling is the update thing shadow, which is this HTTP post call, okay? And then if you look at the example request state document, so we're publishing this desired, because this is what we're controlling. We're controlling from the UI. So that's it. This is really, kind of straightforward. This is the UI, a very simple UI. If you have understood from before example, this is a very simple example here. So this is the front end. So now you can control this on or off on the UI to your LED, and they are not communicating directly with each other. Instead, they're both talking with the broker, MQTT broker, okay? So the UI talks to the broker with a REST API HTTP protocol, and the device on the Pi program is communicating with the broker on the MQTT protocol. Okay, so they're using different protocols here. You see, then they don't even have to be on the same protocol. They can communicate this way, asynchronously. Theoretically, you can use the MQTT on the client side, on the UI side as well. It's just a little bit more complicated to handle this in the browser, all right? So that's why I didn't go that route. So I want to show you something simple. So this is, now you see a different style of building your IoT system. This is, in fact, this type of a IoT application is probably more common than the one that you learned before, using MQTT instead. This is a more realistic. There's one more thing. So I need to show you how to create that access key. So as you see here in the index.html, you see this key here. don't use this one. This is what I created for my account. It's not going to work for you. So you will need to create your own and then update these values accordingly, as well as this endpoint. Your endpoint will be different. Okay. And how do you create that? So let me show you. There's a couple commands that you want to run. This will be shared as well. And so you can actually just use the Cloud Shell. You can use the Cloud Shell, and then there's a couple of commands that you run to actually get that set up. And I'll show you. Let me get the Cloud Shell connected first. It got disconnected, and then it will reconnect. Okay. By the way, you'll notice this IPs are different, right? So actually, because we're idled for too long, and now it's created a different VM here. So first thing you do is to actually get the, let's see, okay. First is you want to get the account ID, and this will actually get the account ID, put that into a, what's going on? Let me see. Okay, account ID. Okay, let's see. It's case sensitive. Okay, so it's got the account ID saved into that variable here. And then actually, let's actually go into that folder. Previously was a W13 folder because we actually have a couple of files in here. We don't want to just have a clean workspace. So we actually need to upload a different JSON document. This IoT policy web.json. This document is a permission document that allows the UI JavaScript client to make those two calls. Remember these two REST API call, get thing shadow, update thing shadow. So this is the thing with the AWS. Every action has some kind of permission control. So it's pretty secure. That's what it is about. So we're going to create this permission and allow us to operate, call these two APIs on this resource. And the resource, we're going to actually use the course name dash something. This is the thing name. Remember that the actual thing name is a CIS-30D-21S dash thing2. So I'm going to use a wildcard here. So whatever that thing you name after that dash is fine. All right. So this is this permission document, policy document that we'll need to use. So you upload this file. So what you do is simply just do the upload here. You upload, select the file, and let's see if we can find this file here. So right here, so let's actually upload. Right, it's done. Actually, when you upload, it goes into the home directory. So well, let's move it out of the home into this folder. So it's IoT to here, right? So now we have this document IoT policy web.json. This is I already kind of show you this. You can actually look at this from this terminal too, if you want. This is the thing that we just uploaded. Now you can run this second command here. This will replace the account ID placeholder into the actual account ID that for your account. So now this is going to actually create that document. So .iot policy. This has this account ID replaced. All right. So this you'll see this has my account ID right here, and then this document itself uses some kind of placeholder here. This needs to be replaced with your actual account ID, like a template, right? So now you have this file. And then now what we're going to do is let's actually create the user. So this will create, for some reason, the copy pasting is not, doesn't look very nice. I wonder why. Let me see. Yeah, that's look, okay, it looks a little weird, but anyway, it works, okay? So you just kind of have some faith here, and okay, you can, copy pasting is a little weird, looks a little weird here, but actually it's working, as I shown you before, and you can also manually type it and just make sure you don't have typos. So copy pasting probably is a better way. So I'm not gonna execute this particular command because I already have this created. I will show you the end result of that. So once you run this command, the end result of this is it's gonna create a user under this IAM service. So user, you see this will be created. This is the user that will be created. And then we're not done yet. We need to authorize the user to be able to execute, to run this API, to be able to, execute this API with this policy. So we'll run this put user policy. You specify the username, and then we'll give a policy name, just the same thing. And then policy document is that IoT policy web.json that we just generated. So you run this command to add a policy here. So you run this command in the Cloud Shell, and the result is going to see something like this here. You see, this is the JSON document that we rendered. Now it's attached to this user. It authorizes the user to do these things. Okay. And then once this is done, we need to get the access key so we can actually use the API to make the calls. So then you run this command to create access key here, given the username, it will generate a security credentials. So now, once you run that command, you can find this thing here. Now, keep in mind though, here is not going to show you the secret key anymore. There's two pieces of information. There's an access key ID, and there's a secret access key. So it can be a little confusing, but there's two pieces of information. Think of it like a username and a password. Essentially, was what it is. Except that you don't usually use this to log into anything. This is for API calls. So you notice here, you're not able to see the actual secret here. And you'll see one piece of information, but the other one is missing, because you only get one chance to copy out the key ID and the other piece of information, the secret. And that is when you actually run this command, the output from this command will contain these two pieces of information. And how does it look? Actually, I'll show you how does it look when you run this command. It will look like this, okay? When you execute this command, you're gonna look at, this is the output from that command. So you need to copy the access key ID. You put that into the index.html right here, access key ID. And the other piece is a secret access key. Kind of a little confusing, right? But this is the secret. The other is the ID. So then you copy this piece and put it over here, okay? And you have to copy this out as an output. If you somehow forget to do it, and then you will not be able to access that information again. So what you can do is, suppose that happened, then you just delete this current access key because you don't have the secret. You just delete it, and then you can run this command again. The command to create access key, create another one. It's free to create as many as you want. So no problem here. Okay. So this is how you do it. You can get this information, you put it into the HTML, and then this is how you can make the call. All right. Now, so here one thing I want to point out, it's not exactly the best way to do it in terms of best practice. You don't want to put your secrets into your HTML file. This is not the best way to do it. Well, in our example, we don't really have a whole lot of alternative here. What really happens in real world is obviously this application needs to have some kind of authentication. You don't just kind of somehow access the application directly, right? So typically you'll have the user log in. So first they need to, present the username and password, or maybe a, two-factor authentication, whatever. They log in. Once they log in, right, with that, the login that whole session is authenticated, then you can actually deliver the information, like this piece of information delivered from the back end. You can essentially have these things stored, let's say in a database, maybe encrypted. Then you can have these delivered to the client side when the user logs in successfully. And then you can use that information to make your calls, okay? But so you do not hard code your secrets in this file, in your source code like this. So I just want to point this out, but we're not doing this here. Just obviously, we're not building a real world application, but this is not our focus here. So this is not exactly a safe way to do it, but I kind of give you an idea how this can be done in a real application. So that's pretty much it. Thank you.